Hey guys, so we're going to do our second video of our lesson 1.1, and this video is going to cover the set builder notation. So the last video we talked about the interval notation. This video we're going to talk about set builder notation, just two different ways to show answers if you have a broad range of them, really. So this is going to use the idea of sets. We did talk about this in the last video, so if you missed that, go back and watch it. But a set is a group of, pretty much in math, it's a group of numbers. And we do list that in little curly braces. But sometimes it's too many numbers for us to list, because a set can be something where you just list a bunch of numbers, like 1, 2, 3, if you have specific numbers as answers. But sets can also be a whole range of values, which would be an infinite number of answers, because even between the numbers 1 and 2, there's an infinite number of answers. So, or an infinite number of values. So, we have to have another way to be able to list things sometimes. And so set builder notation gives us a way to give an infinite number of values just in a really concise way. And interval notation did that too. It's just a different way to notate it. So let me switch over here to see both cameras. Right here. So we got our textbook, yes? Using set builder notation. So we got to break this down a little bit, but your book does such a wonderful job of making this so clear. This is the way that set builder notation looks. You will see the curly braces at the beginning and the end. That talks about it being a set, which is why we call it set builder notation. But the way we read it and we say this out loud is the curly braces tell me to say the set of, and then we put an X. All real numbers X. So we're going to assume that we're dealing with real numbers because that's typically the deal. So the way I'm reading this, the set of all real numbers X, that's why we have the X listed. Then this straight vertical line means such that. It's kind of one of those things that once you get into some upper level math, you will see that more and more the higher you go up, and it's such a silly little thing, but it's something people can get messed up on. So that straight up and down line is a symbol that is supposed to mean such that. And then you'll put a little inequality in there, typically. So in this case, it says X is less than B, but it could say a million different things in there. So some things that you could see here, like set builder notation, it can have multiple inequalities because it could be a broad range of things going towards both negative and positive infinity, but not including the stuff in between. That would be what this top graph indicates. So this would say X is less than or equal to A, or X is greater than B. So it's not including the stuff in the middle. And then here, this is another interesting way to say things. And there's a lot of variance that you're going to see. We'll go through a bunch. But you'll see here X is not equal to A. That would mean that X could be anything except for that one single value. So the way that would look on a graph is just shading the whole thing except for the A value. Okay? So we're going to go through some examples. Set builder notation is really quick and concise, but you will see a lot of different ways that it can appear, and so we need to make sure we can kind of interpret that when we see it. So we're going to look here at these examples that are already kind of done for us, and then we'll do our own. Part A right here, they said to sketch the graph of each set of numbers, and that's one of the things that you need to kind of get used to at first, is being able to visualize what they're talking about. And so that's what the graph does for you. This is saying right here, the set of all real numbers X such that 2 is less than X, and that's less than or equal to 5. I don't know if you can hear that thunder, but it's getting pretty loud. But this is saying that x is between 2 and 5. It is not including 2, but it does include 5. So when we go to graph this, we should talk about shading that range between positive 2 and positive 5. 2 is not included, but 5 is. And you can see that with this graph. Nice and pretty. The next one, part B, this says x, the set of all real numbers x, such that x is less than or equal to 0, or x is greater than 4. So this is saying you're going to be looking at anything less than or equal to 0, so going towards negative infinity, or x is greater than 4, where you would be going towards positive infinity. So you'll see right here, that's what they've got. Right here, they did include 0 because x could have been equal to 0. So you want to include that and go towards negative infinity. Or over here, we are not including the 4 because it said x was greater than 4. It can't be 4. So going to shade towards positive infinity there. Some other ways we could see this, these are a little bit more interesting here. Example 3, part A, it says the set of all integers greater than 5. So you're looking at anything bigger than 5. So you would think of for an inequality, that would mean that x was greater than 5, right? You would use that, the inequality greater than symbol. It is not equal to 5, so you got to keep that in mind. But when we go to write this, we would see the set of all real numbers x. This is what you can see right here. The set of all real numbers x such that x is greater than 5. Now they are including an extra little stipulation here, and I want you to notice this, because this is not actually just all real numbers. This is more specific. They're talking about integers, and I don't know if you recall from the last video, there is a way for us to indicate the set integers. And so you can go back to this page before here. You saw this whole list of things. Integers, we like to use this little kind of double-barred Z, and that is the set of all integers. So that's why you see this little extra inclusion. Because they made that stipulation here that we are working with integers, we have to make sure we include that. So this says right here, that x is an element of the set of integers. And so that E kind of looking thing, that means it is an element. It means it is values from that set, okay? So not only is it values bigger than 5, it is all integers greater than 5. So we had to add in that extra little thing with the Z. Part B, this one's a little bit more straightforward. It says x can be any real number except -1. So it's anything but -1. That's easy. X just can't be -1. And so when we go, we're going to go through a few problems here, 4 through 7 on these monitoring progress. When we go through these, we need to make sure we're keeping everything in mind. And that's probably the trickiest part about set builder notation, is that you have to make sure that you're covering all your bases, because when they throw that curveball and talk about integers, that's a whole extra thing we have to throw into our answer, okay? So we're going to look at these little monitoring progress, if I can get my camera straight. Okay. Okay, so number 4, it gives me a whole range of things. It tells me x such that, so all real numbers x, such that -6 is less than x and it's less than or equal to -2. And they want me to sketch a graph. So we're going to make ourselves a little number line. And I'm usually a little bit lazier with this than I probably should be, but if you do this, then it's not going to hurt anything. To me, I think this just looks cleaner and easier to read. But I know that I'm starting at -6, and I'm going to -2. You don't have to fill up the numbers all on the inside. I think I'm just a little too lazy to, because is it really necessary? I don't think so. So what I typically do is I just put the -6 and the -2, and I don't put anything else. But we do need to shade the right places. So this says that -6 is less than x. It is not equal, so we're going to keep that in an open hole. And x is less than or equal to -2. This one should be a shaded hole, or not a hole, but a circle. And we are looking at all the x's between those, so we're shading in the middle. Done. Boom. Next one, number 5. So this one shows the set of all real numbers x such that x is less than or equal to 0, or x is greater than or equal to 10. Fabulous. So I'm seeing a lot of or equals to things, which means on my graph I should see those little closed points. The two big points that they mentioned were 0 and 10. So again, this is my lazy way of doing it. I don't think we need the other stuff. So this says x is less than or equal to 0. Shade that in, and everything less than it. Then on the other side it said x is greater than or equal to 10, or equals to says to shade it in, and then shade everything greater. All right, number 6. It says, write this set of numbers in set builder notation. So this time we have to think about that. Now remember, set builder has to have that same format. It's always going to start off with the curly braces. We're going to talk about x, right? That's going to be our little thing. So we're talking about the x values, all real numbers x, such that. And right here they're telling me that we're going from -infinity to -1. And then we're skipping some numbers and then saying +1 to infinity. So I'm thinking right here, just reading this left side, this is talking about all numbers that are smaller than -1. So I'm thinking we say that x is less than, and because there is a bracket right here, I'm going to have an or equals to -1. But then we have to talk about this other side, or x is bigger than 1. So we're going to say or x is greater than 1. Close those braces. And last but not least, this is the more interesting one because they throw that word integers right there. So we're saying the set of all real numbers x such that, and we're saying the set of all integers except -4. So this could be an infinite number of answers again. We're saying anything but -4. So x cannot be -4. But because they threw in this word of integers, we have to add in that extra thing telling them that x has to be an element of the set of integers, z. So we're going to add that in as an extra little bonus. I'm going to say, and x is an element of z. And the way I write this z is I kind of just, well, that was a poor example. Usually I make my z's where I just kind of double bar it like that. I did a very poor job right here. But I do just kind of double bar that z usually. And you close that set and you're all set. Okay? Hopefully that gives you a better idea of how the set builder notation works. If you have any more questions, you can shoot me a message on Remind or ask me in class. Look at that. And I'm always more than happy to help you out. Good luck with everything.